So I was just going to do some testing on this, which I've just been given. This is an Akafusion unit, which is used for doing electrofusion welding on pipes and welding pipe fittings on and that sort of stuff. I've done a few videos on these things in the past, so check out the series if you're interested in those. And I was just moving this around. I originally moved it around, there's no signs of any problems, and I was just about to plug it in. I went to go and check the power switch is turned off before I plugged it in, and there's something moving around inside. Now it's stopped again. Yeah, there's a screw inside, I think. Now I had one of these units, it was number 139 was the last one. That had a screw come out of it as well. And this is 136. I checked the history on this one, I've repaired this one a couple of times. I've done the cables on this one a couple of times, these cables always break. People don't treat them with care. It sounds like this series might have an issue with screws coming out inside them. That's concerning. So apparently it's giving an error, but I'm not going to turn it on now, I've got to pull it apart instead. Find out what's actually floating around in there and get rid of it. Last time I had to replace a crystal because it blew the crystal up on a microcontroller, and I got that one working again. But if you've got a screw floating around, it could do anything, couldn't it? Right, let's open this thing up, see what we're dealing with. There it is. It's the same screw it was last time. That is off the back of that board down here. That's what I found last time, it's off the back of there. That's a problem. Looks like there's a design flaw in these things. Alright, let's take this board out. I've already unplugged this and plugged the other things so I could get it around the place. Even that's not very tight. So I've worked on this particular unit before, but I've never touched this part. I've only ever done the cable. And that's just spinning. That's awesome. Here we go, got it. Might be a bit of glue in there to help hold that in place next time. It's got these standoffs in here. I need to do something about that. That's just spinning around. Might just glue it in place. Right. And yep, sure enough, that's where it came from, right there. In fact, I think that's the same one that came out last time, wasn't it? I think it was. Anyway, last time I had to replace the crystal here on the other unit. It's not the same unit, it's a different one. So, yeah, it looks like there's a design flaw with these things where these screws come out because they're not actually the right screws. Oh dear. This could be fried. So what I'm going to do first, I'm going to take all these out. Oh look, that's loose as well. See, it's just falling out, basically. That's loose. That's loose. That's loose. Yeah, it's just like really bad design. There's two of these now, which are both had the screws falling out. Now interesting, I just found that this connector over here was all bent over, and this plug was basically bent at an angle. Now this is weird because, you know, this hasn't separated. I wonder if that's the problem with the error it's giving. It's giving a voltage error apparently. I haven't powered up myself yet, I was getting ready to power it up, and I noticed that was all a bit wonky. So I need to close those pins up a bit, make that tighter, and refit that. Try and straighten these pins up so it doesn't fall off, and then we'll power it up and see if it actually works. So I'm just pulling the pins out. I was going to check them and see what's going on here, find out why they're so loose. It's basically in the back here. If you push right here, it pushes in the tab, which means you can then withdraw the pin. You can't always do that, depends on the kind of plug they are, but these ones you can. I just want to find out why this is so loose, because it shouldn't really be that loose. So I think I just need to basically get in here and stretch this out to make it a tighter fit, then reinstall it. Just do that with it, and then put it back in. There we go. That's better. We'll do the same in the other one. So I bent both the tabs out, pushed it back on again, and it's basically loose again straight away. This plug has had it. Unfortunately I don't have any replacement pins, so I'm going to have to bodge this, I think. Well, I gave it another go, and I think I actually got it okay this time. I think I actually had to curl around the inside part of that pin, not just bend the pin outwards, so I think that's made it a bit better. So I've also put some gunk on here to help hold it in place. I'm hoping that's what is causing the voltage error. Well, let's plug it in and we'll power it up and see what happens. Let's turn on the PowerPoint. Right, it also tripped out here. That had popped out, which is interesting. I just pushed that in and that made it come back to life. Turn it back on. There we go, we have power. Now of course I've got a coil set up on it. It should actually say, yep, good to go. Excellent. let's do a test. I need to get my multimeter set up and monitor the voltage and stuff. Right, let's do this. Should see about 100 volts here. Yeah, that's not good. That did 200 volts. Oh dear, that's not good. See, what that means is instead of actually controlling the output like it's supposed to, it just did full power. It just turned the relay on, did full mains voltage straight through. It's not supposed to do that. It's supposed to step it down to 100 volts in this particular case, and that's not happened. So it's definitely blown up. So I fixed the larger unit previously. It's a different model, a bit larger high capacity unit in the series, and they had a very similar fault. It was basically putting out full power regardless. What that was the Triac and the opto driver were blown. Now it's very likely that because these are so exposed, or these leads are sticking out here, if that screw is floating around inside it like it was, it could have shorted out these leads or something like that and blown this device. I'm hoping that's what it is. It could also be the control circuitry from the IC is blown and it's doing the wrong signals. That's also possible. But my theory is that I'm going to go with a blown Triac. Unfortunately, I think this is different to the ones I've got on stock, so I might have to see what I can do there. But yeah, I think that's likely what's going to be wrong. There you go, I've given this a bit of a rub over. You can actually see the numbers on there. BTA24-600BW. I think I'll have a Triac tester. Damn it. So these are the Triacs I used in the other unit, BTA26800, which are not the same form factor. They're a different package style, so not suitable. Damn it. So I'm going to have to order some parts and just hope like crazy it's these ones, because I actually got no way of testing this Triac. I don't have a Triac tester. I think I'm going to have to buy one now. That's the second time this happened. So it's a couple of weeks later. The parts have finally arrived to replace this Triac. I don't have a Triac tester, so I'm just replacing it blindly, hoping this will resolve the problem. So we need to get the board out for a start. Right. This has been powered off for weeks now, so there won't be any charge left in this thing. It's been a couple of weeks, well it's actually been 3 weeks. Element 14 was so slow to post these things. It took over 2 weeks before they even posted them from the time I did the order. I actually did an order from RS Components and it got sent at the same time as the RS order. The RS Components order I did 2 weeks later after I was sick of waiting, and they both got sent on the same day. Although this one arrived first, it's only just arrived today, so yeah, who knows, the RS one might arrive tomorrow. But yeah, it's just ridiculous. I had to wait 2 weeks and the RS order posted the day after I ordered it. So I should have gone from RS, but Element 14 said they were in stock, but it took 2 weeks for them to post them. Irritating. You know, this is a time sensitive thing, you know, this is something I need to fix relatively quickly, you know, in a decent amount of time, because this is being waited for. It just wasn't actioned very quickly, which is really annoying. What I'm going to do is put some fresh solder on here, and I'm just going to try and get the thing out, and I'll worry about getting the other one after. Just blob it and pull the thing out. There's a lot of thermal mass here, so it's going to take a little bit to get it out. There you go, it's out. I'll clean those holes out and I can put the new one in. So I'm just wicking this up. I've already got one side done. Got a little bit more on this side to do. There we go. That should be clear now. I could have used my desoldering iron, but sometimes wick is actually faster. In this case it was. Just going to clean this up. Already done the one side, or the top side. Going to do the bottom side as well. So what I'm actually doing is replacing just the Triac. I'm not actually doing the Triac or Diac drive, whatever it is, this device here, the MOC3023. I've ordered some, they haven't arrived yet. So until they arrive, I'm just going to try putting this in, see if this is just all it needs doing. If we're lucky, that's all it is. When I did the previous repair on another similar unit, well it's a different style but same functional system, I replaced the Triac and the driver for it. It's basically an optocoupler, but it's got a Diac output on it. And I replaced that as a set. I'm not going to do it this time, I'm just going to do this and see what happens. So I'm going to put some fresh thermal compound on this. Your stuff's a little bit dry. And what I'm going to do is bolt it on and then I'll solder it. Whilst I'm on here, I'm going to check all these other screws as well. It seems these things have a history of things coming loose. Right, that's in. Let's solder it in place. A bit of flux on, just to help it. I'm sure it's got to flow through both sides of the board as well, so that's going to help. Try and get it right through the board. I know you probably can't see too well because I'm blocking the view. And the other side of the board is all flowed through, I think. Yes, so that's all flowed through, that's all good. Let's clean this up. That's the part all installed again. Let's remount the board again and we'll try it out. I hope that's all that's wrong with it. Right, got my setup ready. Multimeter here, this should read about 100 volts AC. This is across this resistive load here. This is a 20 ohm load, which should be about 500 watts around about, if it works properly. Last time this was doing maximum, it's doing a lot more than 500 watts. Turn the power on. It says it's okay so far. Just give me a second to boot up properly. There we go, ready to go. Okay, so it says it's ready to go. So it sets the coil, it thinks it's okay. Watch 100 volts here. If it doesn't do 100 volts, I might have to shut the power off quickly before it trips or something. So push the button. Working. And it's doing 200 volts. That didn't fix it. Oh dear. Well, I guess I'm going to pull it apart again and look at the other device, which is that Diac optocoupler. Maybe that's what's wrong. So let's put some fresh solder on the Diac optocoupler thing here to help get it out. Pin 1's this corner here, so closest to the edge. This side. I might actually have some of these around from when I did the previous repair in the other one, because I think it had the same unit. I'm going to have a look because I need to replace this thing. I was lucky. My rest of the mail bags I had, the actual drivers have arrived, so I can actually put the right one in. Excellent. There we go. Let's get a new one in. Right, so I've cleaned up the circuit board and placed the part in there. I'm going to use a good solder for this one because that flux is driving me a bit nuts really. Clean this up and try it again. Right, let's try this again. I'll put it back together. Let's see if I've got any more improvement this time. I've gone to manual ranging this time so I'll respond faster so I can see quickly or more quickly if there's a problem. Okay, so turn it on. Again, it should only do 100 volts. Okay, let's try it. 200 volts. Nah, still broken. Damn. Well, that's disappointing. Could be fried. I was hoping the Triac would fix it. That was a long shot. It could be the way the Triac's being controlled. Damn it. There's no circuit diagrams for these things either. So I've got to try and figure out the circuitry and figure out why it's doing full current when it shouldn't be. Yeah. So on the back of the board here there's a couple of transistors and a few resistors and stuff around here. I've just checked all these and they seem to be fine. And we've got some, that's an NPN and that's a PNP. Q3 is an NPN, Q2 is a PNP transistor. So I've checked all these parts, they look absolutely fine. There's a resistor there, that's just a bleed resistor for the capacitor. That's a 1K, that's fine. I'm concerned that that screw that came loose has screwed the microcontroller up. I might have to pull this board here back out again, just have a look, see if there's any issues with transistors on this board. Maybe I missed something before. But basically the connector here, you've got two traces here come around. They come up to the optocoupler over here. So this is what's driving it from over here, from these two pins. And it also comes over, trying to get the light on it right, comes along to this resistor here. And it also goes obviously to these transistor arrangements. So I'm not quite sure exactly. I think it just comes along and goes off. I don't think it goes anywhere else. It was check resistance from say here to the pin. Yeah, strict connection. Those two pins basically go straight to the Triac, or the Triac driver, the optocoupler. It looks like the microcontroller is directly controlling that. For some reason it's doing too much power and everything on this board checks out. That's concerning. So I've just replaced two chips on this board here. Now I actually did a call out on Twitter to my followers on there. If you're not following me on Twitter, go and check it out. I'm on there, the Defpom, at the Defpom. and I was querying this chip here because I couldn't identify what it was. I couldn't find it because I thought it said 9341. Anyway, what it turns out, it was a really badly sort of lasered number. It's actually 914I. That's what it actually was, because of the second and fifth digits were definitely different from each other. I thought it was 9341. It's not. It was 914I. Anyway, so that was suggested to me by a couple of people on Twitter and confirmed by someone who had some chips that said that it looks exactly the same. Maybe I'll put an overlay up or something, give him credit. One of the people which confirmed it was Jeremy. He's the one that suggested the number, I think, or confirmed that yes, he thinks that number's correct. Jeremy from Peak Electronics. Hello, Jeremy. Another person whose name's escaped me right now, but I will give credit. Thank you very much. You solved my problem. So I managed to figure out what this chip was thanks to their help. So I've now replaced that chip. I managed to find some. I found that Mauser was the only place that had this chip, and they only had 4 of them. Guess who has them all? I bought all this stock. I've replaced that chip. This chip over here is a basic one. It's like a 393 comparator. Not a problem. Bought a bunch of them as well. So I've replaced those 2 chips. Now I've also purchased these 2 chips here as well. These are some AD736JRZ. Now these things are expensive, right? I only bought 2 of them. These things are like $15 each. I don't want to replace those until I have to. So I'll replace those 2 chips and then we'll test it out. We'll hook it back up again, reconfigure it all, fix anything. If it doesn't, then I'll replace this chip. If that doesn't change anything, I'll replace this chip. If that doesn't change anything, I've wasted a lot of money. I mean, yes, I could be sitting here reverse engineering this board into the integrity and trying to figure out exactly what's going on. I mean, I've done that with the other board, the actual output and the AC input board. I've done that reverse engineering on that one, and I mean, here it is here, right? That's what I figured out from the other board. This is the other board configuration reverse engineered. That one's done. And I've done a bit of mental reverse engineering on this to figure out, you know, what the inputs and outputs are. I mean, I knew this is some kind of op amp or something here or something before I even knew what that device was. The pin out, stuff like that, it matches, you know, what I believed was there. So that was all good. I'm kind of shotgunning it. I'm not doing proper diagnostics on this one. These 2 AD chips here, these are RMS to DC converters. So it's entirely possible that one of these are blown and it's not reading the correct voltages back to the microcontroller. It's entirely possible, which is why I bought those. But then you've got a comparator here, it's comparing signals. It could be that. And it could also be this op amp here. It could be that. Because it is a potential it could be in one of those 4 chips, I've just bought all of them, and I've just done 2. I've done the cheap ones. These are the cheap ones to get. So I'll just do those because that's not much cost. And if that fixes it, great. If it doesn't, then I'm going to have to move on. Maybe if I do those chips and it still doesn't work, I'm going to have to do some reverse engineering. I mean, part of the reason I'm doing shotgunning on this thing is quicker for me to quickly just like replace a chip, right? I'll replace those 2 chips in literally a couple of minutes. Now I've got them. It's quicker for me to do that than it is to sit there, reverse engineer it all, try and diagnose it, figure out what to measure, what it should be, and how to measure it during a test and stuff like that. So it's far easier just to shotgun it and chuck a chip in than it is to actually reverse engineer it and do all that work. That's a last resort. Reverse engineering it is a last resort if you can't figure out easily what's going on. The quickest and easiest path is to just replace those chips. We'll see if we get lucky. Right, I'm set up here. It's all a bit messy because I don't want to reassemble everything fully because it doesn't work. It could be wasting my time. So it's connected together. It should function. These should be mounted into this panel here, which obviously it's not right now. I've just got to make sure nothing's touching that it shouldn't be touching, but I think we're good there. Don't forget this is 240 volt AC running on. Use this to look at the readings. I've got it manual range 600 volts. Hopefully it responds quick enough. So what should happen if it works correctly, this voltage should go to about 100 volts until I stop it. If it goes in more than 105 or so, for example, then something's still wrong. What I've seen before is doing about sort of 200, 220 volts, something like that. Basically putting full output. So I'm hoping that by changing those 2 chips it's fixed that. We'll find out. So I've got the power switch turned on over here, so I have to touch it. Let's turn the switch over here on the Diac. Well, my auto transformer. So we have an LED here. We should get a second one pop up which says it's detected the fitting. There we go, LED 2. So I should be able to come over here and touch the start button over here and have it work. Nah, 200 volts, it trips out as well. No good, not fixed. Damn. All that means we've got to replace these expensive chips. So I'm just going to do one at a time. I'll do this one, we'll try it again. If it still fails, we'll do that one and we'll try it again. Yeah. I might as well show you doing this one. So it's just, I put some flux on, a bit of fresh solder on it, just to help it desolder a little bit. I'll do the other side, and then I'll get the hot air and desolder it. It's a shame because these are the expensive chips. I didn't want to replace these ones unless I needed to, but oh well, it happens. Right, so what I'll do is start blocking the camera view. Pin 1, I'm pretty sure it's this bottom corner. I'll have to double check without dropping it. I try not to heat the capacitors up. There we go. So double checking pin 1 is bottom left corner. Trying to do this while the board is still warm, if I can. I'll come and refloat again afterwards as well. Looking alright. So I'll clean all this up and I'll come back and retest. Right, let's do the same test again. Power on, I've already done the reset. Got the first green light, we should get the second green light. Yep, second green light's on. Let's push the button and see what happens. That 190 volts again. Wasn't that one? Now I was actually trying to remember before about which screw came out, because I remember finding there was, the screws from this board came out, right? That's what I found. I think it was this one here was out. It was this one or this one. One of those bottom ones are falling out. So it made me think maybe this one which has been damaged, right? Because it would have been this area. So what I'm going to do now is the device I took out of there, I'm going to move to here. See no difference in performance. And I'm just going to say get an original device and put it into this position instead, and we'll see if that changes anything. I mean, basically we're still replacing it. This is one which over here which appears to not being fixed, so that one was probably fine. I don't want to put brand new parts on this so I can avoid it. Those things aren't cheap. I won't bother recording me changing it. I mean, you saw me do the last one, you get the idea. Right, let's repeat the same test again. Get that part replaced. Power it up. Got the first LED. Wait for the second LED. I'm really hoping this one fixes it. No, 190 volts again. Damn it. That didn't work. Well, that's the simple diagnostic stuff done. I can't really go any further than that right now because I've done individual component tests. Like I've checked every single component on the board, like checked transistors, diodes, resistors, measured all the resistor values, that sort of stuff. I've gone through, done all the discrete devices, can't find anything wrong with any of them. So I left it basically being down to the semiconductors. And well, as you know, I've now replaced 4 of them and it's still doing it. So it's either the microcontroller's dead and it's not working correctly, maybe it's got a shorted output or something, I don't know. It's not reading input properly or something. Yeah, I thought replacing those would have solved the problem and it hasn't. So that's really not a good thing. So I might have to resort to reverse engineering this board as well, and that's going to take me forever. I've had this thing for ages now. Literally I've had this thing for about 2 months. And I've been chipping away at it, testing things and trying different things, and I only recently found out what this chip was. So, I ordered those straight away since I figured out what those were. I'm running out of ideas. You replace all the 4 chips, you would think it would be that, but I've verified everything else seems to work, so I'm running out of ideas here. It could be the microcontroller. If that's the case, then that's it, it's done. But yeah, I made a mistake before. I said I got these chips from Mauser. That was wrong. I got them from Arrow. Mauser didn't have any. I tried Mauser, DigiKey, RS, Element 14, Arrow. They're actually really good, very fast and stuff like that. And they only had 4 of those chips, and I took them all. So good luck finding some. Right, I've just tried something now. I did notice that there was a component missing off this board, and it's the only component missing off the entire board. There's no other components missing, just the one. And it looks like it's from a voltage divider circuit, and it does relate to the Triac control. So I've just tried substituting a part in there. I just put in a resistor, which is a 1K. I've just taken a pure guess based on similar circuitry on the board. They've used 1K throughout in lots of other places, so I thought, right, I'll chuck a 1K in there, because it could be the right part, and we'll see if it changes the behaviour at all. I don't know, we'll find out. So I've got power coming into it. I've got to be careful not to touch anything around here because this is all live. Alright, all this stuff here. This is 240 volts around there, so I've got to be careful. And I've got a power switch on the side I've got to flick on, which will hopefully activate, and if we're lucky, we'll get 100 volts over here. If we get 100 volts, then it's fixed. If we get more than that, it isn't. Some of these indicators. It's going to get a bit grainy, I think. There you go, you can just see that one now. So there you go. So a green indicator for OK. Another one to say it's detected the fitting. So let's try doing a weld. And hopefully we get 100 volts. No, 200 volts. I'm getting very close to calling this thing and saying it's not repairable, because I cannot find what is wrong with it. I mean, there's some more tests I could potentially do, which is like actually comparing the inputs and the outputs of the op amps and the comparators, and actually calculating what they're actually doing, make sure they're generating the right stuff. I've checked the power supply rails, I've checked every single component on the board, both boards, and I cannot find anything wrong. So I'm at the point of thinking it's probably a blown processor, or it's the other processor over here, which does like a PWM signal. I think they should be getting a 100 kilohertz coming to it from circuitry over here, and that then does something. I don't know what it does, and that's used on a comparator. So yeah, I could bring it right down to that level, but I'm getting close to saying it's just not worth fixing anymore, because I just can't get any further than this.